Whenever you first learned how to solve multi-step problems, you probably learned Please Excuse My Dear Aunt Sally, or PEMDAS. PEMDAS is a way for us to remember the order of operations when we're solving a multi-step problem. So P is for parentheses, E is for exponents, M is multiply, and D is divide. Notice that those are grouped together. And A is for add, and S is for subtract. Again, notice that those are grouped together. So if we encounter a problem like this, we're going to take care of what's in the parentheses first. So the 2 plus 7 gives us 9. And then I would do the multiplication by 5. So I end up with 45 as my answer. Here's another problem. This one includes both multiplication and division. So whenever we encounter a problem like this, multiplication and division have the same priority. So how do we know which one to do first? So that's where the other part of PEMDAS comes in, which is that we always go from left to right. So in order to solve this problem, I would start with 40 divided by 4. That will give me 10. And then I would multiply that by 5 to get 50. If we did it the other way, if we did it the wrong way from right to left, we would do 5 times 4, which would give us 20. And then I would do 40 divided by 20, which would end up with 2. So I get a very different answer if I go from right to left. So remember, left to right is the correct way to do these multi-step problems. Let's go ahead and look at how this will apply to an actual problem with significant figures. So when you are performing multi-step problems, you need to keep track of the significant figures as you complete each operation, but you don't want to do any rounding until you get to the end of all of your calculations. So for example, let's say that I want to do this. So first I need to take care of what's in the parentheses according to my order of operations. So I'm going to do 1.5 plus 2.33. So when I add these up, I get 3.83 as my unrounded answer. So in order to round this for Sigfigs, I would need to draw a bar over the last significant place in each of my numbers. And I'm going to round to the bar that is furthest left. So I'm going to round to the first decimal place. So 3.83, next to the 8 is a 3, so that 8 is going to stay the same. So my answer rounded for correct significant figures in that step is 3.8. But when I go back to my problem and I plug that in to next do my division, I'm going to keep that unrounded number. But mentally, you're going to remember that 3.83 is actually supposed to be 3.8, which is 2 sig figs. So I'm going to go ahead and do my division here. So I get 6.03149 as my unrounded answer. So whenever we multiply or divide with sig figs, we have to count how many sig figs are in each number. 3.83 is 3 sig figs, but remember, if we had rounded this, it would have been 2 sig figs. My other number, 0.635, is also 3 sig figs. So even though 3.83 is technically 3 sig figs, if I were to round this answer, I would have used the 2 sig figs, so this number is going to round to 6.0. Let's go ahead and take a look at a slightly more complicated example. So in this example, I've got 2 sets of parentheses, I've got multiplication, I've got an exponent, and I've got subtraction. So according to order of operations, I'm going to take care of the 3.64 squared first. So that gives me 13.2496. Now remembering the rules of sig figs, whenever you multiply something, you just have to count how many sig figs are present. So 3.64 is 3 sig figs, so my answer when rounded should also be 3 sig figs. Now I'm going to go ahead and take that unrounded number and do the next operation, which in this case is going to be subtracting 3.12. Now I'm going to remember that this 13.2496, if I had rounded it, it would have been 13.2. So I can go ahead and get my answer. And since we're doing subtraction here, we need to round to the least precise number, which in this case would be the 13.2. That means that my answer here should only have 1 decimal place. Next, I'm going to go ahead and take care of the multiplication. Once again, instead of using 10.1, I'm going to use the unrounded number in my calculation, but I'm going to have to mentally keep track that it's supposed to be 10.1. So I'm going to go ahead and do this multiplication. and I get 76.9950896. And I'm going to go ahead and, since this is multiplication, count the number of sig figs. So 7.601 is 4 sig figs, and the 10.1296 was really supposed to be 10.1, which is 3 sig figs. So I need to round this answer to 3 sig figs. So I end up with 77.0 as my correct answer. If I had rounded between each of these steps, and instead of using the unrounded number, I used the rounded number, I would have ended up with something a little bit different, 76.7, if I had rounded between the steps.